So we are wrapping up our unit. There is one last thing that we need to talk about, and that is kind of bringing a couple things back together, kind of bringing it around. One of our last units dealt with linear equations, linear functions. This unit was exponential functions. There are a lot of similarities, a lot of differences. They both have equations. We have graphed both of them. One of them we saw arithmetic sequences. The other one we saw geometric sequences. They both created patterns in our information. I want to kind of bring both of those things together, and it's the last thing we're going to do before we're done with the unit. So we are going to call these nodes linear versus exponential. Let me move this up. Zoom out. Oops, wrong way. Okay, so label your notes linear versus exponential. So we're just going to spend a little bit of time comparing the equations of both, the graphs of both, what they each look like in tables, which is arithmetic, which is geometric, that type of thing. And we'll talk for a second about situations for both. All right, so the first thing we're going to look at is, let's look at the graph. Okay, so we have two different graphs that we're going to see for linear and exponential. Does anybody remember for a linear equation, what does the graph look like? Can you describe, after you plot your points and you connect them, what do you draw? Or what does it make? Abigail? Makes a straight line. Okay, and by straight line, we don't mean horizontal, vertical. We mean a line that doesn't bend, doesn't curve, right? So, good job. So for linear, we have a line that's created, right? So creates a line for linear, hence the name linear, right? Unfortunately, exponential doesn't match the word, but we've been working with exponential equations and they create curves. Right? Can't technically call it a line because lines don't bend, they don't curve. All right? And if we take a second and draw kind of a rough sketch, so give yourself a little coordinate plane. Doesn't have to be perfect or pretty. It can be, yes, it can be. And we have our line for our linear equations and some sort of curve for your exponential. And give them a little label. All right. So they are different in their shape, right? One is straight, one has the curve. When we think back to what we did yesterday with the rate of change, linear equations have a constant rate of change, okay? However, like whatever the slope is in one spot, it's going to be the same in every spot, right? So everywhere we go on our linear equation or our line, we're going to have the same rate of change every single time, right? The exponential had different rates of change, and that's why yesterday's homework was important, because when you looked at like the runners at the beginning, the rates of change changed. That's why we called it average rate of change. Okay, so with our linear equations, we had a constant rate of change, right? So make a little note. Constant rate of change. That means the change didn't change, right? Or the rate of change doesn't change. No matter what 2 points you took on the line, the rate of change was the same. You can think of it as consistent. Okay? But you'll hear people say constant rate of change. For our curve, we ended up with an average rate of change, or with our exponential. We had an average rate of change because the nature of a curve is in different spots, the slope was different. We saw that, right? Bless you. All right, so next up, we're gonna look at the equations. All right, so does anybody remember the general format for a linear equation?
Is it y equals mx plus b?
What, yes it is. Y equals mx plus b. If we were to use numbers, the m is a number, the b is a number, right? So for example, y equals 2x plus 3 would be an example of a linear equation. Our x is a number that's being multiplied by our slope, right? For exponential, that was where we had the big long equation. We had those like that packet that had the 2 or 3 pages, right? Where we had the big long equations. Anybody want to try to remember exactly, or kind of? There is a plus k. There is an x in a subtraction situation, but it's not minus x. You're close. You're getting there. It's a big one to remember, Isilia.
It's something like y e to the x minus 8. No,
Okay.
y equals a times b at minus 8 plus k.
Sweet. Yeah, that's a big one. Good job. It does come back up as you guys go through school. The linear is the one that's going to come up the most often. That's the one, if you haven't memorized that, definitely memorize that. This one, memorize it for the test. Memorize it when we get to the end of course exam. And then you'll have that formula when you need the formula. So an example of what it would look like with numbers, the y and the x stay y and x, everything else gets a value, right? So like 2 times 4 to the x minus 3 plus 7. The only thing that won't have a number is the y and the x, because those are the ordered pairs within our graph, right? So that's an example of what exponential would look like. And if you look at the comparison, because in today's homework, you're going to be given an equation and have to decide, is this equation going to be linear? Is this equation going to be exponential? So if we think about, they both have a y equals, okay, so the y would have to be able to be isolated, right? But if we look at the x's, in our linear, the x is a product, or a part of a factor, I guess. It's part of the product between the slope and the x, right? In our exponential, the x is an exponent. That's a key feature. If the x is in the exponent, you have an exponential equation. Okay, so if the x is in the exponent, it's exponential. Say that 3 times really fast.
X is an x.
Excuse me. All right, so that's the key. If the x is like one of the factors within your addition problem, linear. X is the exponent, automatically exponential. All right, the last one we're going to look at here in our notes is the table. So you do need to be able to tell from a table whether your function is exponential or linear. So I'm going to give you two tables, but I'm not going to tell you which is which. And we're going to see if we can figure it out. Give yourself a little space above it to the side so we can jot a couple things down after we go through it. All right, so here's our first table. And here's our second one. Get those copied and then take a second and see, can you figure out which one would be exponential, which one would be linear? What is this? All right. All right, so which is which? So Isalia, what's the first one? Exponential. And so this one's linear. What do you guys think? Okay, so Isalia, say you told me, but tell everybody what made you decide this one was linear.
Just every one, the x is going up. Okay, so x is going up one, and then the y goes up like two.
So we add 2 each time, okay? So because we have a constant rate of change, right? If we look, as the x goes up by 1, my y's increase by 2. So the rate of change from y to y is constant. That's a clue that it's linear, right? If you think back to when we did our sequences before, they were arithmetic sequences. Arithmetic sequences create linear functions. That's why we learned arithmetic sequences while we were working with linear functions. So make a little note that this is arithmetic. An arithmetic sequence is a sequence where you add or subtract the same thing over and over. And we got done talking about geometric sequences a couple weeks ago, and those created exponential functions, right? So if you look at this first one, as my x is increased by 1, my y's are increasing by different amounts. However, there is still a pattern. What's the pattern? So we're multiplying each by 4, right? So my pattern is that I'm multiplying by 4. And yes, that's a consistent pattern. However, when we look at the rate of change, so if we look at how the numbers are changing, if I were to get the slope from each set, my slope here would be 6. The next rate of change is 24. The next rate of change is 96. So because my change is changing, it's exponential. And if you can kind of think about the graph of what the graph would look like, if I had a point at 0.2 and the next point at 1.8, 2.32, you can imagine like that curve is going to start kind of slow and go up real fast, right? This is a geometric sequence. Geometric sequences will create exponential equations. So there are a couple different ways that if you were given a table, you could decide which is which. You could look and decide, is it an arithmetic sequence? Is it a geometric sequence? You could look and see, is it changing by the same amount every single time?
And this is average, right?
This would be like you would have to find an average rate of change if you wanted to try to like get a slope of this graph. But then again, it's so hard because some part's going to be flat and then it's going to get real steep, right? Okay. And just like the runners, right? Different parts, it was a different kind of slope. All right, the next thing, and we're not going to put this in your notes, we're actually going to talk about it when you get the assignment. On the homework, there are a couple parts where we have like situations that you need to look at and kind of decide. So I'm going to give that to you, and then we're going to quick talk about it. But this is all we have for the whole rest of the period because I want you to be able to get the homework done. And on Friday, we're just finishing up the unit. I want you to be able to finish your practice, green practice test from last week. Remember I gave you the practice test, you had like 6 or 7 problems to do for that last quiz. And then there were a bunch that you didn't do, whatever's left is what you're gonna work on to prepare for Friday. I do have the quiz that you guys took last week that I'm gonna give you back in a few minutes too. So take this paper, this is your homework, you're doing 1 through, it says 11 on the board, but it should be 12. I don't know what I was doing. But if you don't do 12, we'll do 12 right now. So get that passed back and let's take a look at it really quick. I want you to look at the problems that have words. Bless you. All right, so you'll see on the paper that we have graphs, tables, equations, but if you look at 5 and 9 and 8 and 12, we have words. So a couple things to remember, look at what's written very carefully. Bless you. Function is decreasing at a constant rate. We wrote something in your notes that will help you determine if that's linear or exponential. Okay, so something decreasing, exponential and linear both can have a decrease or like a decay type situation, but which one would have a constant rate? Damien. Which ones do we have the rate doesn't like change from one to the next? Linear. So linear has the constant rate, right? You also are going to have to explain your decision. So you'll have to come up with how you describe that that's linear. If you look at 9 says each term in a sequence is exactly a third less than the previous term. So when you took a sequence and you would either increase it by a third every time or decrease by a third, increase by, when you take a third of something, are we multiplying or adding? I take a third, if I take a third of the number of 9, you're multiplying, right? So of is the multiplication word. So if I took a third of the cookies in the jar, and there are 9 cookies in the jar, I'm not subtracting a third, I'm actually multiplying by a third. I'm taking 3 cookies, right? So when we multiply by the same thing over and over, it's what type of function? Exponential, right? So when you look at the words, if it's something that's lends itself to something that gets kind of multiplied over and over, then we know it's exponential. If it's added or subtracted over and over, we know it's linear. On number 8, it has a percentage. Whenever you take the percent of something, of means that we multiply. Usually, anytime you see of, it's a multiply, sometimes a divide, but mostly a multiply word. And then 12, when things double, you multiplying or adding usually? Multiplying. Yeah, so that's kind of how you deal with the wording problems, but you're going to choose if it's linear or exponential, and then explain your decision. That's going to be part of the points, explaining decisions. Got it? Questions? right, good job, you guys.